right, so we're going to look at exponential functions, kind of sort of that application of part of that. And this is going to be the growth and decay model of exponential. So things can grow very rapidly or decrease very rapidly. So the decay is the decreasing and the growth is increasing. So here's your growth and decay formula. This is something you will have to kind of sort of memorize or know. It's not on your formula chart. And to my knowledge, you could possibly have to use it. So it is something that you need to make sure you kind of sort of understand where it's coming from. A is kind of sort of the ending amount. That's what we're basically going to be solving for every time. C is your beginning amount. All right. Plus or minus, that's going to tell you either growth or decay. So growth would be plus, decay would be minus. And then you have your rate, which is R. And so how fast is it increasing or decreasing? And then T is your time. How long has it been increasing or decreasing? And your rate will tell you. So if it's increasing at a rate of 4% every month, but it is over 3 years, you have to make sure that you put your T in months. So that's kind of sort of something you want to make sure you kind of sort of are aware of. It says a cell that is 0.03 millimeters on day 1 grows at a rate of 25% each day. How large is the cell after 1 week? So I don't know my ending amount. My beginning amount is 0.3. And then I have 1. 1 is always going to be there. That tells you I'm taking the previous growth and adding my rate or subtracting my rate each time. So then I'm going to add. It's growing at a rate of 25%. You can put 25% in your calculator. I really would like you to do it as a decimal. So do 0.25. And then raise to the time. Well, it says each day and it says after 1 week. Well, there are 7 days in 1 week. So your time is going to be 7. Even though it says 1 week, your time is going to be 7. So you would plug this in your calculator and see what you get. And so you'll get 0.014 millimeters. That's how big it would be after 1 day. Let's look at the next one. The population of giraffes has been declining for several years now. In 2000, the population was 140,000. And they are declining at a rate of 4% per year. What is the current population of giraffes? So I'm finding my ending amount. I start out with 140,000. I have my 1. I'm going to take the previous, that's what that 1 does. It takes the previous amount every time. And then I'm subtracting 4%, which is 0.04. Move the decimal 2 places to the left. And then it says, what is the current population? Well, it says per year. It's been 17 years since it's been 17 years since 2000. So it's another way they can kind of sort of trick you up. And so then plugging that into your calculator just exactly like you see it, you would get your solution. And you end up with 69,942.2. Well, I can't have 0.2 of a giraffe, so it would just be roughly 70,000. So it might ask you kind of sort of what's an estimate. Roughly 70,000 giraffes are currently in the world. And this is really pretty accurate. I looked it up. It's actually roughly to 80,000 left. So pretty accurate. That's decreasing at a rate of 4% each year. So kind of sad for the that population. All right, so this is exponential growth and decay. You do have to memorize your formula. Your ending amount is your beginning amount, 1, plus or minus your rate to the time power. All right, so that's exponential growth and decay.